change the f of x to y, and then switch the x and the y, and then solve for y. So I divide by 3. Okay, once you solve for y, you change the notation. Okay, and I'm going to skip the graphing part for now, but these lines would reflect over the line y equals x. Okay, same 4 steps. I'm going to replace the f of x with y. And then we're going to switch the x and the y. Then we're going to solve for y. And since you want y by itself, you're going to take the cube root of each side. So then you have y equals cube root of x minus 1, which is the same thing as f inverse of x equals cube root of x minus 1. Okay, so switch the f of x to y. Then we switch the x and the y. We solve for y. Now normally we would say plus or minus square root of x, but because we're talking about the restricted function, because remember up here we said we could only use the positive side, so then that means we're only going to use the positive root. So then this would be f inverse of x equals the square root of x. Okay, so let's switch the f of x for y. Switch the x and the y. Okay, and then we want to solve for y, so we're going to square both sides. Okay, we're going to subtract 16. I'll put it here on this side. I'm going to divide by negative 1. Take the square root of both sides. I just rearranged the terms there. Now, it's a positive or negative root, but notice that we're looking at the negative x values. Okay, so then that means that we're going to get the negative root here. So then f inverse of x equals negative square root of 16 minus x squared. Okay, so let's go ahead and change the f of x to y. Switch the x and the y. And then leave y by itself, so I'm going to cross multiply. So I can divide both sides by, oops, sorry, it should be y inside. We're going to divide both sides by x. Then we're going to square both sides. Okay, so then it's going to be y equals 36 over x squared. And then change it to function notation, so it'd be f inverse of x equals 36 over x squared. Okay, so 119 and 120 are true false. It says for 119, if f is an even function, then f inverse exists. Well, let's just take our basic even function, which is the parabola. So does this one have an inverse? And the answer is no, because this function is not 1 to 1. It fails the horizontal line test, so this would be false. And then for number 120, if the inverse function of f exists and the graph of f has a y-intercept, then the y-intercept of f is an x-intercept of f inverse. And that one, again, if you know that your graph intersects right here, let's say at 0, 1, then we know that the inverse function has to intersect at 1, 0. It has to. So yeah, this is true.